Okay, so let's recall. We did the part 1 of the fundamental theorem of calculus in class. Just remember that now anytime we say big F, we're talking about the integral of the integral from a to x of f of t dt. All right, so for those of you, whoever was absent today, I just wanted to kind of put these up so that you can stop it and write down what you missed. That's page 1. Page 2, this was a review of the chain rule. Okay. And once you've completed, don't forget to do that problem and we will check the work tomorrow. And now we're on page 3. So we did not get to this in class, so let's review. So Fundamental of Theorem of Calculus, FTC, Part 2. Basically what this is saying is if f is continuous at every point of a and b, and big F of x is any antiderivative, aka integral, of f of x, that is, the derivative of the integral is f of x. Okay, so remember what we stated before, that f of x, so calling it big F, is basically saying the antiderivative of f of t, okay, dt. So whenever we say big F, we're saying the integral. Now, if I take the derivative of the integral, that is going to equal the function itself. All right, so the integral from a to b of f of x dx is basically taking the integral of f from b minus the integral of f of a. This is really just evaluating the integral the way that we've always done so, okay? But it's just the notation that you have to remember. So in other words, find the value of the antiderivative at the upper limits minus the value of the antiderivative at the lower limits. This is also known as integral evaluation formula. Remember, when integrating polynomials, for each term you raise the power by 1 and then divide by the raised power. Okay, so the integral of x to the n of dx will equal x to the n plus 1 divided by whatever that n plus 1 became. So this is just review again, okay? So let's look at this problem. Do we know how to integrate this polynomial? So this literally has nothing, almost nothing to do with the first part of the fundamental theorem of calculus. So, do you know how to integrate this? What is the integral of x cubed? It's x to the 4th over 4 minus 2x squared over 2 plus 3x. Now, it would be plus c if it wasn't defined, but I'm not going to put the plus c there, so this is 2, negative 2. Now, I could clean this up before I get started, but if you plug in 2, so we're going to start here. So this is 2 to the 4th, which is 16 over 4, minus 2 squared, which is 4, times 2 is 8, divided by 2 is still 4, plus 3 times 2 is 6. And I'm going to take this and I'm going to subtract it. Now I'm going to plug in the bottom one, the lower limit. So negative 2 to the 4th is 16 over 4 minus negative 2 squared, which is 4, times 2 is 8, divided by 2 is still 4. And then here, 3 times negative 2 is negative 6. Subtract all these out, so 16 over 4 minus 16 over 4, that cancels out. Negative 4 minus a negative 4 is the same thing as saying negative 4 plus 4, so that actually cancels out. So all we're left with is positive 6 minus negative 6, which is 12. So the second one is, what if we had a radical? It's still the same rule. You're still going to add 1. Now the difference is when we add 1 to 3 halves, we have to do so as a fraction, okay? And basically here we're doing x to the 3 halves plus 1 over whatever 3 halves plus 1 is. And that, what is 1? Remember, we got to get a common denominator. So this becomes x to the 5 halves divided by 5 halves. Flip the guy and multiply to get rid of this double division, so we end up with 2/5 x to the 5 halves from, now we got to integrate, 5 to 1. Plug in the top one, so this is 2/5 5 to the 5 halves minus 2/5 1 to the 5 halves. And if I simplify this, this is 2/5 5 to the 5 halves minus 2/5. They both have a 2/5 in common, so I'm going to take one out. See, without a calculator, you're kind of limited as to how your answer is going to look like. Now, 5 to the 5 halves is the same thing as saying it's the square root of 5 to the 5, right? Minus 2/5. And honestly, the only reason I wrote it like this is just to see if I could simplify this easily. Oh, and this is supposed to be a 1. Sorry, guys. 1. Now, 5 to the 5th is going to be a very big number. And the square root of 5 is not going to be easy. So actually, I'm going to keep my answer looking just like that. Okay? So sometimes it's not possible, but if it is, you have to figure it out. And because this is 5 to the 5th, there's no way to square root it evenly. Alright, next, there are 2 ways to do this. You can either use the additive property, basically by splitting up. Okay, remember, you can split up the integral from 0 to pi of 1 plus the integral from 0 to pi of cosine of x. But this is easy enough where we can do, what is the integral of 1? It's x, plus, what's the integral of cosine? It's going to be negative sine, the integral of cosine is going to be sine of x. Remember, it's not the derivative, it's the integral, so don't confuse those negatives, which I almost just did. Alright, so it's x plus sine of x from pi to 0, and then you basically plug in pi plus sine of x, sine of pi, minus 0 plus sine of 0, and what do you end up with? So sine of pi is going to be 0, and sine of 0 is 1. Right? Why am I confusing this? Oh, and sine of pi is 1. That's why I'm ending up with the wrong answer. All right, so here, sine of pi, remember, pi is going to be over here. So sine of pi is going to be negative 1 minus 0 plus sine of 0, which is 1. So negative 1 minus the 1. What am I doing wrong here? I'm doing something wrong because the answer should be pi, but I'm doing something wrong because right now my answer is ending up to be negative 1 plus pi. I don't want this video to be forever, so figure out what I did wrong, if I did something wrong, and let me know. Okay? All right. This last example, before you guys started, I want you to change this to sine of x. And it's going to be the same exact thing. So what is the derivative of 1? It's going to be x, or the integral. I keep saying derivative, I'm sorry. And then the integral of positive sine of x is going to be negative cosine of x. And the way you can always check yourself is ask yourself, what is the derivative of x? It's 1. And what is the derivative of negative cosine of x? It's positive sine of x. That's how you check yourself to make sure that you're right. Go backwards. And this is going to be from pi to 0. And plug in pi minus cosine of pi minus 0 minus cosine of 0. Do the math. So this is pi minus negative 1 minus 0 minus 1. So here we have pi plus 1 minus negative 1, which is the same thing as saying pi plus 2. Okay? And what I was telling you guys earlier is you can use the additive property and do this. Take 0 to pi of 1 plus 0 to pi of sine of x. It's the same exact thing, except you're just integrating individually. And sometimes you might have to do that to be able to integrate trig functions. So it still ends up being the same. Okay, so this is pi minus 0, and then this is going to be negative cosine of pi minus negative cosine of 0, which is the same thing saying plus. And you'll end up with pi plus 2. Okay, because that's going to be our negative 1, and that should have been a 0. And that's going to be our 1, but because we are adding, so this is negative 1 plus, again, I'm doing some kind of math wrong here. So this is negative cosine of pi. Cosine of pi is negative 1. Oh, because cosine of pi is negative 1, and then there's the negative, so that's going to be 1 plus 1, and that's 2. Alright, I want to do this together in class. I'm going to start you guys off, and basically the easiest way to do these problems is turn them into a negative exponent first. So this is y to the negative 3 minus y to the negative 4. And now when we integrate, you're going to add 1. So negative 3 plus 1 is going to be y to the negative 2 over negative 2 minus y to the negative 3 over negative 3 from 1 to 1/2. And now you can rewrite it. Now you can bring this back down. So in order to integrate, bring them up. And then once you've integrated, you can bring them down, because look how easy this becomes. So this becomes negative 1 over 2y squared minus, or plus I should say, because there's two negatives here, so plus 1 over 3y cubed, from 1 to 1/2. And now you can plug this in, plug in the 1, so negative 1 over 2 plus 1 over 3 minus minus 1/2 squared, which is going to be 1/4, times 2, which is what number am I getting? So 1/2 squared, which is 1/4, times 2, which is going to be 1/2, plus 1 over 1/2 cubed, which is 1/8 times 3 over 3/8. Okay, and then I'll let you guys finish this up. And remember, flip the guy and multiply. So really this is just negative 2, and really this is just 8 over 3. Agree? So one more step. Keep saying I want to stop. So this is just negative 2 plus 8 over 3. And now you can finish up and get the actual answer, which ends up being negative 5 over 6. Okay? Alright, so the fundamental theorem of calculus part 2 is just exactly what we were talking about before. Okay, so really the most important part is remembering the first fundamental theorem of calculus. So how to study? Let's do these problems tonight for homework. And then if you wanted to even go through the examples in the textbook, because they are different than these examples over here. So go through those and see if you have any questions, if you have time. If not, we will talk about the examples tomorrow. And then tomorrow night, your homework is going to be the video notes for section 5.5. All right, enjoy.